All right, guys, here we go. We're going to talk about absolute value equations and inequalities. The absolute value of a number is its distance from 0 on a number line, regardless of the direction. So as you already know, the absolute value, if it equals k, that number that can be plugged into the absolute value is either negative k or positive k. Here's an example. If you have an absolute value, you have to get that by itself first. So the first step on this one is to move the 4 to the other side by subtracting it, and you get negative 2. Still have to get the absolute value by itself, so you divide both sides by negative 2, and you get 1. Now the absolute value is equal to either the positive of 1 or the negative of 1 inside that absolute value. I have a magic trick that's called drop, stamp, negative. So you take the absolute values and drop them off. You stamp the equal sign on the other side of the equation, and then you put the number that's on the right over on the left as a negative. So drop the absolute values, stamp the sign, and put the negative of the number on the other side. At this point, you have 3 sections to your equation. You want to get the x by itself, so you would add 1 to all 3 sections, and then you want to divide all 3 sections by 2. 0 divided by 2 is still 0, middle is x, and the right is 1. So in set notation, your 2 answers are 0 or 1. Looking at the second property, the multiplicative property of absolute value means that if you have 2 things multiplied together in an absolute value, you can separate them into individual absolute values. So when you're solving this next problem, you're going to want to try to get the absolute value by itself first. So you move the 1 to the other side, and you get 6. You divide by 3, and you get 2. And then these 2 things multiplied together inside the absolute values can be separated into their individual absolute values, and you can take those separately. Absolute value of negative 4 is 4. And again, you want to get this absolute value by itself, so you move the 4 to the other side by dividing, and you get 1/2. And then if you do drop, stamp, negative, drop the absolute values, stamp the sign, put the negative number on the other side, and in this case, you're done because you have x by itself. So your 2 answers are negative 1/2 or positive 1/2. Okay, we have 2 more examples, 2 more properties dealing with inequalities this time. First one is when it's less than. X is going to be bound between the positive of the value and then the negative on the other side. This is any distance where any value of x where the distance is from 0 is less than the value of k. So if we're looking at this first problem, again, we're going to use that same idea of getting the absolute value by itself first. So the first thing you want to do is move the 1 to the other side by adding it to get 5. And then you get rid of the number in front of the absolute value by dividing. So you move that to the other side by 5 divided by 5 is 1. Again, I'm going to use the 3 magic words, and those are drop, stamp, negative. So you're going to rewrite the absolute value equation without the absolute values, so drop them off. Stamp the inequality sign to the other side, and then put the negative of the number on the right on the left, so it's negative 1. This is now bound between the negative value of k and the positive value of k, which is negative 1 and positive 1. Now you've got 3 sections again. You're looking to get x by itself, so the first step is to add 2 to all 3 sections, so the middle now does not have 2. So on the left you have 1, in the middle you have 3x, and on the right you have 3. And again, then you get the x by itself, you're going to divide by 3 to all 3 sections. And then again, you're going to have 1/3 is less than x is less than 1. If you're graphing that, this is bound between the values of 1/3 and 1. You're not going to have them equal to them, so you're going to have open parentheses and shade in the middle. If you're doing interval notation, x is an element in the interval from negative 1/3 all the way up to 1. Looking at the last problem, this is the same type of thing. You have absolute value inequality again, but this time we're going to have a greater than symbol. There's going to be a break in the graph. You're going to have it less than the negative value of k, or you're going to have the value of x being greater than the value of positive k. So in this case, in this example, we're going to get the absolute value by itself first again. We're going to move the 2 to the other side by adding it to get 9. You divide by 3 to both sides, and you get 3. Now you've got your absolute value by itself. We're going to do drop, stamp, negative. So drop the absolute values, stamp the inequality sign to the left, put negative on the other side. Now get x by itself by subtracting 4 to all 3 sections. You're left with negative 7 is less than x is less than negative 1. If you logically think about that, that doesn't make sense. X can't be bigger than negative 1 and less than negative 7. So this one is so great. If it starts as a greater than when you did the drop stamp negative, this is going to split into an or. there's going to be two parts to this answer. The first one is where x is less than negative 7, and the second part is when x is greater than negative 1. If you look at that graphically, you're going to have the values less than negative 7 is an open parentheses shade left, and then the value at negative 1 is open parentheses, and it's greater than, which shades to the right. So it's split into two sections. If you do this in set or interval notation, x is an element of the set where it goes from negative infinity all the way up to negative 7, or, which is the U symbol if you're doing set notation, is going to go from negative 1 up to infinity. And that's it. Now that I feel like an idiot talking to my computer, hope you have a good night.